we just saw that trigonometric functions can be expressed as functions of a central angle instead of an arc length. Kind of neat. But how can we find points on the unit circle if it maybe isn't a nice angle? Okay, so we're gonna look at some examples. The first one actually ends up being pretty nice, but if we pretend for a minute that we only remember the first quadrant, right? So I'm gonna draw the unit circle, and we have 3 pi over 4, which ends up being quadrant 2. So here is the angle theta is equal to 3 pi over 4. Okay. How can we determine the point on the unit circle? So this is just an unknown x and a y value using what we saw with the first quadrant. Well, if you remember, our work before said that when theta was pi over 4, right, we had the point on the unit circle that was square root of 2 over 2, comma, square root of 2 over 2. Okay, now all we're doing for 3 pi over 4 is reflecting it across the y-axis, right? So vertically, we're not moving at all. It's just horizontally we're changing. So if we do that, the point here would retain whatever y value it had, so square root of 2 over 2, and the x value would change to its opposite sign due to the reflection. Okay, so didn't even need to use a calculator. I could have also looked this up on the unit circle. It happened to be a nice angle, but this would be an instance how you could find other points along the unit circle's perimeter that correspond to a nice angle. All right, so maybe something that isn't as nice. So we're not going to use a calculator because we don't need it, right? Calculators just slow us down sometimes. I want to think about that statement actually, but in any case. All right, say theta equals 7 pi over 3. Where in the world is that on the unit circle? I really don't know. 7 pi over 3. Okay, so I know that this is 0. This is pi. Let's say I have pi over 2, 3 pi over 2. Okay, so 7 pi over 3. Oh gosh, that's like 2 and 2 pi plus pi over 3. So it'd be like 2 and 1/3 pi, right? Okay, so I wrote it this way because it's actually a full rotation around the unit circle. So we would go around the unit circle once, and then we would go a little bit more, right? And I would find that it is coterminal. So if this is 7 pi over 3, it would be coterminal with pi over 3, right? And that happened to pop out right there. Okay, so if I wanted to find the point on the unit circle that corresponds to this, right, it's the point there, it's the same point that's coterminal with pi over 3. Okay, and then I can whip out my unit circle or do other math. And this is going to end up being 1/2, comma, square root of 3 over 2. Okay, so then with this, I can say, oh, okay, now I know the point on the unit circle. I can evaluate the 6 trig functions. So let's do that. So sine, and I'm going to do theta, right? And I'm just, I'm going to do sine theta, cosine theta, tangent of theta. And then, let's see, I have cosecant of theta, secant of theta, and cotangent of theta. So let's complete each one of these. So sine is just the y-coordinate over 1, so square root of 3 over 2. Take the reciprocal of that, 2 over square root of 3. Or if you wish to rationalize it, you multiply by, rationalize it. Multiply by square root of 3 over 3. I'm going to give you 2 square root of 3 over 3. Okay. Cosine is 1/2. Take the reciprocal of that for secant, just 2. I was going to write 2 over 1. 2 is just fine. Tangent, square root of 3 over 2, so the y-coordinate over the x-coordinate. Or if you simplify that, it's just square root of 3. And I'm going to move to cotangent because I need a little bit more room. Cotangent would then be the reciprocal of tangent, 1 over square root of 3, which if you rationalize it as square root of 3 over 3. Yay, math. Okay, big point here. Again, drawing out the angle is super helpful because then that allows us to see, or it allows us at least to figure out a coterminal angle if needed. Okay, and now it says, what point on the unit circle corresponds to a central angle of 5 pi over 7? Okay, so this is interesting because 5 pi over 7 is not on the unit circle. Okay, so how in the world do we do this? Well, again, getting a little sketch might help. 0 pi, pi over 2, 3 pi over 2. Okay, so 5 pi over 7 is bigger than pi over 2, right? Because 5 over 7 is bigger than 1/2, but it's less than 1. So it's going to be somewhere over here. Okay, so I'm going to label that as 5 pi over 7. Okay, and I'm looking for this point P of x, y. Okay, still a little stuck, but here's what I also know from the picture, right? Whatever my answer is, I know that if this is the point, that x needs to be negative because it's in quadrant 2, and y needs to be positive, right? Okay, so still stuck. What do I do? What do I do? Here's what we remember. We remember that on the unit circle, cosine of theta is equal to x over 1, or simply put, just x, and sine of theta is equal to y over 1, or again, simply just y. So to find x and y, just substitute in the central angle that we have. Equals x, and then sine, not 5, 5 pi over 7 equals y. And so now in your calculator, make sure that if you're entering in radians, that your mode is set to, so mode has to be set to rad. Okay, it might be in degrees by default, but on your calculator, find the mode button, make sure you change it from degrees into radians. Sometimes instead of a mode, you might have a button that says DRG, and this is degrees, radians, and gradients. So you just press that button and you can change it from degrees to radians. Okay, so look for that button, or mode. Okay. In any case, if you do this on your calculator, you should get that x is approximately, and I'm going to use double wavy line to indicate approximately, negative 0.62, and y is approximately 0.78. Okay, so then in total, our point is negative 0.62, or I should say approximately 0.62, 0.78. And that's it. Okay, so big takeaway is to remember that on the unit circle, and I repeat, on the unit circle, cosine is x, sine is y. Okay, so just some other interesting problems connected to trigonometry and trig functions of angles in particular.